They put all these here. And look, they still have one of those. But you haven't seen one of those in a while. It's got a VCR and everything.
That might your teacher was hungover when we were kids.
Oh, elementary school. Anyway, okay, so you start with these two distributions. One is centered at mu0. One is centered at mu a. I'm going to go through this conceptually. I'm not going to do numbers.
Right.
Conceptually meaning with variables.
Variables.
Alright, so first step is, you're going to act as though you're calculating you're conducting a z-test. So you're calculating a z-statistic. And the way you do that is you take the mean you have and subtract the population mean. Right?
Mm-hmm.
Good so far. And what you end up with is another little set of, I'm just going to save myself some more space here. You end up with the same distributions, but transformed. So this is now 0, right?
Mm-hmm.
And this guy is now at whatever this z value is that you calculated. Makes
Right.
sense?
And
Yeah.
but you're basing the means off, but the mu0 and mu a are based off of already z values, or you're going their original median values.
These are just in the raw units. These are in
Right.
transformed units. Good?
Okay, so you just turn mu0 into 0. You're not worried about actually calculating it out.
Yeah, well, I mean, you could. mu0 minus mu0 divided by
Right.
the standard error, and you get 0.
Right. But since you're going to get mu a, you just
So
put
so,
mu0 0.
Right.
Okay.
Yeah. So I'm sorry, that actually is more simple than it sounds. Which is nice. It's nice when things are less complicated
Yeah.
than they seem. All right. Okay, so last step here. Okay, the reason we do this transformation, right, is because we want to see where we would actually reject the null hypothesis. So looking at this distribution, we need one more thing from this. What is it? Where would we reject?
We need the critical value.
We need the critical value. So that's going to be some number. It could be a number on this side. It could be a number on this side, in which case you're screwed for power. It could be two-tailed, in which case you're still okay, but it would be a little bit more extreme. We didn't go over that. You don't have to worry about it too much, but it's just, basically has the same effect as an adjustment on alpha, right? So if you go from a one-tailed to a two-tailed test, you're effectively reducing your alpha level in one tail. But okay, anyway, we've got our critical value. So we've got some z value, ZCV, that is your critical value. And what you need to do is, okay, we're done with the normal distribution now. What we want to calculate is this area, right? The area under the alternative distribution where we are going to correctly reject the null hypothesis. And so we want to standardize this critical value in terms of this mean. So this is a mean here. I'm going to call it z mu a, so you know that's the z-score that corresponds to this mean. And then what you do is you just do another little z calculation.
Right,
so
you'll do
you
z.
Z equals the critical value minus the z of the mean, and then you divide by the standard error of the standardized distribution, which is just 1.
At this point, it's
Right.
1.
So this is just 1 here. because we've already divided by the standard error. So when we're looking at these standardized distributions, they have standard error of 1. Yeah, so this transformation then gives us gives us a new distribution where this is the center, right? So let me draw that. So we have distribution centered at 0 here. So this one literally just, I drew that poorly, but that's the center, and this is at 0, okay? So C mu A goes to 0, and this critical value is now this Z value here, okay? Yeah, and then we just look up that area in the Z table. Alright, so we started with the 2 distributions. One is true under the null hypothesis, the other is true under the alternative hypothesis. They can't both be real. To conduct a hypothesis test, we assume we have this distribution. To calculate power, we assume we have this distribution, but we still need to think about this one because this is the one that our test is based on. So we have to start by saying, okay, if we were to calculate or conduct a hypothesis test, we would start here, we would get a critical value, and we would reject if we have a value bigger than our critical value. But if we're actually interested in this distribution, if this is really true, then we don't care about this anymore. We only care about the area under this distribution where we're actually rejecting the null hypothesis. We want that area to be big. So if the alternative hypothesis is true, then we can calculate this area using this little transformation here. Make sense?
So towards the end, you're pointing to the Z because...
The Z, that Z is that critical value from the previous.
So yeah, this is the critical value from this distribution, the null distribution, that we would use to conduct our hypothesis test.
Yes.
If we get a value over here, we're going to reject the null hypothesis. And if the alternative hypothesis is actually true, we want to do that. So we want to calculate this area where we would correctly reject the null hypothesis, and that would be done assuming this distribution is the real distribution.
And the reason why that's the Z on the bottom is because when you look up that Z in the Z chart, it'll tell you the percentage between the mean, you have that section between the mean and that, and you use that to add up the percentage between Z and the mean, and then you add 0.5 for the other side of the table.
So this is a little tricky. I'm actually going to change my notation here a little bit. So this is a critical value here. I'm going to call this the critical value, and then we'll call this Z of the critical value. Because otherwise it's a little bit meta where you have
Right.
the Z critical value of the Z critical value. But yeah, this is the critical value. You get a transformation of that according to the alternative distribution, which is centered at the Z score of this, right? And then you do the calculation.
And that's giving us the power in the bottom
This area
is the power.
is the
The
power.
power.
Yeah, and then this area is what? This area that's not shaded.
That's the null hypothesis.
It's the beta.
That's not an area.
That's the.
Beta.
A hypothesis is like a statement.
Yeah, no,
Yeah,
it's the.
areas under curves are probabilities. So when I ask what an area under the curve is, you better be giving me a probability.
Probability that we fail to
Reject
reject the
it.
null hypothesis.
No, that we reject.
The probability that we fail to reject the null hypothesis, given that, which of these is true?
Oh, given that the alternate hypothesis is true.
Right. And what is that? Which error?
Type 2.
Yeah, that's the
Yeah.
probability of committing a type 2 error. So this is beta. So another way to think of power is
You said beta.
1 minus beta. Yeah. So this is P of type 2 error equals beta, which is this area.